Warm up. Using the diagram below, find each measure. First, they want us to find x. All right. You can see that we're given a couple different radii, but this right here is not a diameter, meaning that it is not a straight line forming a straight angle, 180 degrees. Okay, you can't assume that. So the only way we could have found x was to add all of these angle measures together, all these central angles, and set them equal to how many degrees in a circle? 360. Yep, 360. So 4x plus 1 plus 7x minus 4 plus 42 degrees plus that right angle, 90 degrees. That has a total of 360 degrees. So quickly solving that, I got, my markers have been kind of wacky today, x to be 21. Okay, next one says find the measure of arc JM. That's what this notation means. Arc, M means measure. JM is talking about this one. So they're not asking for the length, they're asking for the measure. So that is the same as whatever the central angle measures. Okay, so I do 7 times 21 minus 4 to find that angle. I got 143 degrees for that central angle, meaning that arc would measure 143, and make sure you put degrees. Okay, this next one's kind of confusing because technically they didn't specify which arc they're talking about. They said find the measure of arc JL, and there's two ways we could form arc JL. We could go through K this way, or technically JL we could go this way as well. If they wanted us to differentiate it, they should have told us like JKL or JML. So I'd accept either answer. I interpreted it as this arc. So I plugged in 21 in for x here, and then added 90 to that. So I think I got 175. If you interpret it as that other arc, I'll dash that one, this one, that would just be 185. Yeah, 185. So I would accept either answer. Okay. All right. Next problem says use the circle to the right to answer these two questions. And if you notice the difference of these now, once they give us some information, we're actually finding the length of the arc and not the measure. Okay, first problem here, number 2, I guess. RM, which is a radius, is 8 inches. Find the length of arc QP. This one right here. So when I want to find the arc length, this is that one where I set up the proportion. Anyone remember the little proportion, kind of like formula thing? Lillian?
Is it L over 2 pi r is equal to x over 360?
Perfect. Good. L over 2 pi r. So whatever piece of the circumference that my arc length is, it's proportional to the piece of the central angle of the entire circle is, which is 360 degrees. That's where that proportion comes from. Good. So we need to find the arc length. And we know the radius is 8. And we know the angle formed by that arc is 72 degrees. That's how you would set up that proportion. We're trying to find QP. Okay, to solve this, you cross multiply. So we would do 360L. All right, a really easy way I taught you to multiply this, so just do 72 times 8 times 2, which is 1,152, and then use pi, just like that. Divide by 360, get in the habit, and I think I do this on the answer key. I give the exact and I give the decimal. Do I? Yeah, okay, good. That's how I want you to do it. I want you to tell me the exact. So remember, to find the exact, you just simplify this fraction here, this improper fraction. I get 16/5. And then you stick pi up there. There's the exact. Okay, if you don't know how to do that, practice that on your calculator before tomorrow. As a decimal, you just times 16/5 by pi. I got about 10.1 inches for this arc length. Okay, there's your answer for number 2. 3 is very similar. So I want to find my arc length. I'll use red for this one. Arc length of arc PQS. Okay, so this time they're using the 3 letters to notate which arc they're talking about. P to Q, and then to S. This arc length right here. Okay, I don't want to know the measure. I want to know the length. So I do the length divided by 2 pi r. All right, my radius changed. This time they told me NP, that's another radius, is 13 feet. So divided by 2 pi 13 equals, ooh, did anybody calculate this angle right here? What'd you get, Brianna?
252.
What'd you get?
Yeah,
252? 252? Me too. 252. How'd you do it, Brianna?
I subtracted the 103 from the 180, and then I added. That gave me 77.
This one?
Yeah.
Okay.
And then I
Added those 3. Good. We know this form's 180, so you could have also done 180 plus 72 also. Whatever way you're going to do it. Whatever makes sense in your head. Okay. Now we solve. Cross multiply. 360L equals 252 times 2 times 13 is 6,552 pi. Divide by 360. I like to show my work when I divide by 360 because it's a little reminder, oh yeah, I just have to simplify that fraction. You can see it right in your work. I got 91/5 for that fraction. So again, just multiply the pi into the numerator. That's 57.2 feet. If you want to check if your answer makes sense, find your circumference. See if 250 degrees, that maybe looks like it's about 3/4 of the way around. See if that number is about 3/4 of your entire circumference. If you get a circumference that's less than that, you did something wrong, right? If the whole distance is less than that length, you did something wrong. Okay, today, really pretty short lesson. Talking about some relationships with chords. So let's review over some of our vocab here. A chord is any segment that its endpoints lie somewhere on the circle. So in this picture right here, AB would be considered a chord. You could also call that BA. Diameters are technically classified as chords. But what differentiates a diameter from a chord, a diameter is specifically a chord that passes through the center. So my only diameter here would be BC. Okay. Other vocab review, arcs, because we're going to talk about arcs as well. Minor arcs are arc measures that are less than 180 degrees. 180 degrees arc lengths are semicircles. So anything less than that, such as arc AB. This is how you notate arcs, my friends. Or you could say arc AC or CA. Order doesn't matter in these ones. Those would be minor arcs. Any arc larger than 180 degrees, when we're talking measure, is a major arc. So I could do CBA. I could do ACB. Those are both examples of major arcs. All right, that's just a little vocab review. Here's one of the big ideas for today. If we know that 2 chords are congruent, meaning the same length, then we know 3 things about these. So let's look at this example. If we know DE, that's a chord. If we know that is the same length or is congruent as another chord, such as GF, here's one thing you can conclude. The arcs that these chords form are also going to be congruent. So this arc right here, measure and length would be the same as this arc right here. And that makes sense. If you picture taking a chord, like, I don't know, like literally a stick on a circle, and you just keep placing it, it's always going to section off the same amount of the circle, right? As long as that stick doesn't change length. Their central angles are also congruent. So remember, central angle is the angle it forms with the center. So this angle and this angle would be congruent. I'm going to fill these in as well here. So the two chords are congruent. So arc DE would be congruent to arc GF, what I did in green. And then the central angles would be congruent. So the measure of angle GCF would be congruent to the measure of angle DCE. Okay, this one's fun. The chords are also the same distance from the center. When we talk about the same distance, we need to assume we're talking about the shortest distance. Okay, because you could start your sentence here and be like, well, wait, if I went all the way like this, that's way longer than that distance. We're talking about the shortest possible distance here. Okay, so let me get rid of that. What is the shortest distance from a point, the center, to a line? Tyson. Good. Perpendicular. Perpendicular distance. Yep, they form a right angle. So the shortest distance, remember we talked about that like a couple times? From here to here, try to find like the perpendicular distance. And same thing from here, center, to this chord. Those are going to be the same distance. All right, I'm going to call this X and this Y, so we can write in our notes here that CX is congruent to CY. The distance from the center to the chord. I had to start X. Okay. As long as the chords are congruent, all three of those things are true. Again, you can kind of like visualize this. That's a nice thing about geometry. Kind of visualize why that makes sense. We're going to try a couple of example problems with this. That's basically half our lesson though. All right, in this figure, circle A is congruent to circle B. Remember, all circles are similar, but in order for two circles to be congruent, the diameters or the radius length have to be the same. All right, this is what they tell us. Arc WX is congruent to arcs YZ, and they marked that for us. Find the length of WX, which is a chord. All right, so this is kind of almost what we talked about like backwards. Before, we knew that the chords are congruent, which made their arcs congruent. So would it make sense that if we knew the arcs are congruent, we could then conclude the chords have to be the same length as well? Yeah. All right, so if they're forming the same arc, length, or measure, these are also going to be congruent. So how could I set up an equation to solve for X, Brianna?
So the equations equal to each other?
Equal to each other. They have to be the same length. All right. Solve this quick using math. X is 4. Unfortunately, the problem that say find X said find WX. So WX is 7X minus 2, 26 units. It's as easy as that. I wouldn't even have to plug X into YZ if they asked me to find that length, because I know it's the same. It's also going to be 26. Okay, next one. In circle P, PF is the same as GH, which those are both chords, and they're both 24. Okay, they told me these are both 24 or they're congruent. Find PQ. So the reason why they're showing me these right angles, exactly kind of what Tyson said, that's the shortest distance from the center to those chords. So that like third piece we learned here, right here, this third piece, we know the chords are the same distance from the center. So similar, we know these distances are going to be the same. Set the equations equal to each other, and we can solve for x. PQ is 2. Just kidding. Almost plugged it into PR. Doesn't matter though. Should get the same answer, same distance. 12 minus 3, 9 units. Okay. That's basically like the first, it's not really a theorem, just like relationships with congruent chords. Second piece of this lesson, the other thing we need to know. This one is kind of cool. I have a nice little visual for this. If you have a diameter or radius of a circle, and if it's perpendicular to any chord in the circle, it's going to bisect the chord, okay? Or it's going to like pass through its midpoint is another way to think of bisects. Bisects means split in half, right? So we can see here in this picture, AB is a diameter. XY is a chord. And so what this theorem is saying is if these are perpendicular, it's going to bisect that chord and split it into two congruent pieces, or it's going to like pass through its midpoint. Okay? Now, it not only bisects the chord, but it also bisects the arc that the chord forms. So like this arc would be split up into two congruent pieces as well. All of that information just if we have a perpendicular chord to the diameter or a radius. Okay, so in this case, XZ would be congruent to YZ, and arc XB would be congruent to arc YB. Okay. Here, I'll show you the visual now while you're writing that down. Okay, so in purple is the, well, it's basically a line, but it's the diameter if you were to stop it here. And here's a chord. So watch what happens as it kind of like moves around the circle. Now it doesn't show you this, but these, they're keeping them all perpendicular. That's what it's kind of like doing over here in these equations. It's keeping these perpendicular. So no matter where the diameter or where the chord is, you can see it's always going to pass through. They're showing you the midpoint, so it's always going to bisect that chord. Split in half. And if you look at this arc, it's bisecting that arc as well. So it's splitting that in half. Pretty cool, huh? Do you guys just want to watch this the rest of class?
Please.
It's kind of satisfying, right? Okay. That's enough of that. That's my visual for you. This one is, ooh, I accidentally just saved this. Dang it. That's okay. Not the end of the world. No! I didn't even hit that either. There. That's what I wanted. The 4K percenter is probably going to pop up, but that's okay. This one is kind of like the converse, kind of. If you know it's a perpendicular bisector, the chord is. So if you know the chord is being bisected and it's perpendicular to this other segment, then that other segment has to be a diameter or radius. So if we went kind of back to like that visual we're looking at, there's no way we could take a chord and draw it in a perpendicular bisector and it wouldn't pass through the center, is basically what that's saying. Okay? All right, let's try some problems with this theorem. In circle G, the measure of arc DEF is 150 degrees. Find the measure of arc DE. All right, well, they're showing us here that this radius is perpendicular to this chord, which means three things. It means it splits this chord in half. So even though they don't ask me for this segment right here, it also needs 5. And it splits the arc in half, aka bisects the arc. So if this whole arc was 150 degrees, what's half of 150? 75. The measure of arc DE is going to be 75 degrees. Okay, that's all that was. That's all that problem was. The next one's kind of fun. What's going on here? Okay, the radius of circle W is 23. The measure of arc DE is 60 degrees. DE itself, I'll maybe write these in here. So the measure of arc DE is 60 degrees. DE, the chord length itself, is 37. And we know DE, chord DE, is congruent to chord AB. Okay, this kind of goes back to that first thing we were talking about. If the chord lengths are congruent, that means these arc lengths are also going to be congruent. So right away, it asks you to find the measure of arc AB. It's going to be the same as ED. Since those chord lengths are congruent, it's going to be 60 degrees. Okay. Now it wants us to find the measure of arc BC, just this piece. This is where this little perpendicular marking is going to come into play. Now they're showing us a radius is perpendicular to this chord, which means it bisects the chord and it bisects the arc. I'll just do squiggly. So if that entire chord, we just found is 60 BC, it's going to be half of that, 30. Okay, bear with me. I knew that from the perpendicular marking. Find AB. That would be referring to the length, right? It doesn't give me the arc symbol, AB. What would the length of that chord be? 37. They're congruent. It's that easy. 37. We're actually going to bop down to BC. All right, so Matthew just told us this is 37. Earlier, I told you when you have a radius or diameter that's perpendicular, it bisects it. So to find BC, we're just going to need to take half of that or divide it by 2. 18 and a half. Almost thought 17 and a half for a second. 18 and a half. You can put units if you want. Okay, this next one's fun. WF. I'm just going to kind of erase some of these markings quick. Okay, so notice F is this point right here. I'll highlight this in green. They want me to find WF. Now they tell me that the radius of circle W is 23. Is what I just highlighted a radius? No, it's just shy, right? It's just short of a radius. So it's not 23. But I know this distance is 18 and a half. Same reasoning as why BC was 18 and a half. I know this distance was 18 and a half. And what I can do is I can draw a radius from W to D. I know the radius length, no matter where I draw it, I could draw it over here, over here, over here. The radius length is 23. I know these are perpendicular. You guys seeing this? How could I find this? Okay. Pythag. I have a little right triangle right there. Hold on. All right. X squared, my 2 legs squared, plus 18 and a half squared, plus equals 23 squared. Folks, I'm okay if your original side length was given to you in decimals. I'm okay with you doing decimals for your answer. You don't have to do simplest radical form. Okay, those are those numbers squared. Subtract over the 342. I get this number. Square root both sides. I get this number. 13.7. So meaning WF. 13.7 units. About. I just rounded to nearest 10. Okay, only one more. In this circle below, diameter QS is 14 inches long and chord RT is 10 inches long. Find VU. Okay, tell me this. 10 inches. I need to find VU. Okay, it's going to be kind of similar to the one we just did. I see these are perpendicular. I know the diameter length, so I could form another little radius. I mean, you could draw a whole diameter if you want to. I know that entire diameter would be the same no matter where I draw it, is 14. So this little piece right here would be 7, that radius. Okay. Now, since this diameter is perpendicular to this chord, it bisects the chord, meaning this would be 5. Meaning I could find VU by using Pythag again. Everybody see that? You guys awake?
Yeah.
Come on, guys, we're on the home stretch. Finish strong. All right, this one we don't have decimals, so let's write our answer in simplest radical form. So that's 4 times 6, so 2 root 6. And as a decimal, I got 4.6. VU, 4.6 units. Talking about a length, so go ahead and put units on that. That's it. Good times. Thanks for watching. Okay.